Hello, we're Team 3B and we decided to call ourselves the Curly Wallies. We're looking at challenge number 3, which is Scope 3 emission analysis. We've approached the challenge from the point of view of the Chief Executive, who expects reporting on Scope 3 emissions to soon be in scope. And he wants to be ahead of the game. So, as a regional manager, I want to see up-to-date information on Scope 3 emissions for the areas I'm responsible for and understand my region's contribution to the company as a whole. I want to be able to drill down to locations and sources of Scope 3 emissions, including employee commutes not currently recorded or calculated. As a strategic director, I need a tool to provide me with actionable insights to aid planning of interventions that provide the biggest impact to Scope 3 emission reduction.
The different travel fare sources, that's from the different locations from Argentina all the way down to the United Kingdom. And the next step was to identify the key metric fields for visualization and for our to fulfill the requirements of the brief. And that was the travel dates, the carbon emission data in question, that's the kilograms CO2 emission, and also the source and destination locations. The next step was to clean the data using the Power Query functions to standardize and just make sure that the data in each of those sources was consistent. Because we found out that some of the data sources or some of the locations did not have the correct metrics. Some of them were not in English, so we had to convert some of them. Some of the carbon emission data were in tonnage or in completely different units. So we had to make that conversion so that everything will be standardized. The next step was to export that sheet, that created sheet, into the Power BI and create these filters and also new metrics and to create the visualization outputs, the trend over time, and also the charts and maps. Thank you.
After analyzing the data, we realized that we did not have a distance from the employee's postcode to the office. And as a result, we used the Google Maps API to find a route that was suitable and provide us with a distance that we could then convert into a CO2 value to assist with the Scope 3 emissions analysis.
Approach for the consumable data, we had to convert it into something we could use. So transform the information into a carbon dioxide consumption. So for the office consumption, that is how much carbon emissions are generated by each office in the UK. We did this by measuring the footprint of the building using Google Maps, looked at the number of floors in the building to calculate a total metre squared floor space, and then converted this using a conversion factor to give us the kilograms of carbon dioxide. Similarly, for electricity and gas, the same thing. We based this on 240 working days in a year. The amount was working from home, and then again using average consumption and information to convert that into a carbon usage. Finally, for paper, again, we had the amount of paper that was used and converted it to a consumption value.
So I'd now like to just walk you through the product that we've developed. This is the cover screen where you can see an overview of all the data. And the key thing to note here is that we have two different streams of data. On the top, we have the current situation that we've calculated, but on the bottom, we've got an option to model data based on changing 3 key variables. Now, I know that there's many variables to reducing carbon emissions, but we've chosen to focus on 3 ones that were available from the data we had. We looked at reducing flights, so using this year's data as the base point, what would happen if we reduced the number of flights? The same for paper, and then the same for how we balance the work from home balance between offices and home working within the company. Now, this one is particularly interesting because as emissions from homes go down, emissions from offices potentially go up and vice versa, and that will also impact on commuting. So I'll come back to these towards the end of the presentation. I'll quickly flick through some of the detailed information that we've got, information around business travel, where we can look at things like the impact of the COVID lockdowns, looking at things like the most emissions per route. We've used the term consumables to cover CO2 from offices and from work from home, and also from paper usage. So again, all of these factors are covered on the consumables page. And with commuting, we've looked at lengths of commute, distances, all that kind of thing, which you can see in this map. But the most interesting bit, and the bit that I'd want to spend the most time on, is to kind of visualize what this looks like in terms of reducing carbon. So we've tried to find several key measures which show just what a reduction in CO2 equivalent carbon looks like. And this is where these prevention tools can come in. You can start sliding the values around. So if we reduced flights by 50%, you can see different kind of impacts on the CO2. The key one is the work from home, because the work from home is from such a low benchmark, where in the data most people were working from home. You can see that if everybody went back to the office, the total carbon would go up considerably, because at the moment only 5% of people are going into the office every day. So this is the kind of thing where a CEO or a managing director could start to see what the impact of various policies are on the fly and get a real understanding of what that looks like in terms of environmental impact.
So whilst we think the solution we've put together is pretty amazing, there are some things that we can see can be future developments to take this further. Certainly, we recognise the need to standardise travel data across all sources. So that means we can get the same level of information on flights from all countries, and then can incorporate error checks that can improve the quality of that data, make it sure it's timely and we get regular updates, or that we're then feeding in real-time information. We can see that the dashboard can be made as a Power App, certainly to make it more user-friendly. Further to that, that could incorporate functionality for employees so that they can see Scope 3 emissions associated with their activity and what changes to their actions can make to the overall emissions of the company.
A motivated hacker will be most likely to attack a dashboard as they are a HR database. A company will already store personal data for their employees, such as name and addresses. However, the data used to determine the Scope 3 emissions does not require the names or specific house numbers. The process uses the employee's postcode or departure and arrival location for flights. For extra data security, alternatively, the first 3 characters of an employee's postcode can be utilized. However, this will reduce the quality of the data as the distances from the home and office commutes may vary.
I believe that this would allow the users at all levels to understand emissions associated with decisions from a strategic and also individual standpoint. It would allow comparisons and identify more efficient office spaces, and also to see the growing trends and act upon them. It would allow the users to also model impacts of their behaviors. It would also allow for better facilitation for top-down and bottom-up improvements, and generally encourages that employee buy-in and commitment.
The third question the judges have asked us is, how would you handle error checking and making sure the data is clean? What steps can be taken to make sure that all the data is valid? So we've identified that future development would need to go back to the source so that we can use a consistent format to collect data from all of the sources. It would only be for information required for the purposes of the Scope 3 emission reporting. This would then incorporate use of Power Apps and Power Automate or something similar to collect the data from the different sources in exactly the same format and provide a clear, consistent process that's followed, and also for set data fields. It ensure that the data is more complete and can identify errors and then reduce any missing data. And then also further development could include code to automate error checking and avoid duplicates of the data and